Oh yeah, that's on, okay. So my name's Mark from Intel, and first of all I'm just going to talk about what OPNFV is. So there's a few members of the board here, they could probably describe it a little bit better, but I'll give it a shot. So OPNFV is the open platform for NFV, and the goal of OPNFV is to produce a de facto standard carrier grade open source platform for NFV. And the reason why they're doing that is they're trying to enable NFV products and services in the industry. But I suppose behind all that, OPNFV really is a community, and it's a very large, fastly growing, diverse community. You can see how diverse it is here. There's 55 member companies, all under the umbrella of the Linux Foundation. And they all have different areas of expertise. There's hardware vendors, software vendors, there's silicon vendors, and service providers. And the members, the attendees that come to the conferences and do the work are quite diverse as well. So there's standards guys, coders, network guys, DevOps. It's quite broad. And it's very fastly growing. So last year there was 0 developers working in OPNFV. And this year we found out there is over 100 developers working in OPNFV, and they've produced something like 2,000 commits into the OPNFV repositories. And that doesn't really include all the commits that they may have done in some of the related upstream repositories as well. They're very active. There's mailing lists, a lot of mailing list conversations, IRC conversations, and those type of things. So what does OPNFV do? So for those of you who may be familiar with it, Etsy defined a reference architecture for an NFV platform. And what OPNFV is trying to do is it's trying to instantiate the Etsy reference architecture using open source components. So the initial focus of OPNFV is the Vim and the NFVI in the NFV reference architecture. The NFVI is the portion of the stack that provides network, compute, and storage services up into the virtual workloads running on the platform. And the Vim, which is the virtualization infrastructure manager, is the thing that is kind of managing those resources. So what they do is they take a lot of open source components, so things like OpenStack, OpenDaylight, Open vSwitch, and they build them, they integrate them, and then they deploy them on an OPNFV compliant platform, and they do some validation and testing of performance and NFV use cases. And they do that all in a kind of a continuous integration framework. So in the process of doing that, they also identify any gaps, feature gaps or performance gaps in the components, and then they try to address those gaps. So how they do it entirely working in the upstream. So there's no intent to kind of fork any project. What they want to do is they identify these gaps, they fix them, and then they try to push them into all the various upstream components. And then they release their integrated code on a reasonably regular release cadence. So we've had one release this year, which is the Arno release. They're named after rivers. Arno, as Daniele probably knows, is a river that runs through Pisa. And the next release, early next year, will be the Brahmaputra release. So within OPNFV, there is a load of different projects, and the projects have different areas of focus. So they focus on things like the infrastructure. So there's a project called Pharos, which deals with the hardware platforms and the lab infrastructure. There's testing projects like the Func Test project, which tests the functionality of the platform, and various other component projects. One's for installers, one's for other software components that's being used for OPNFV. However, I suppose the 3 important projects for this community are the ones I've highlighted here. So VS Perf, which is a project to characterize the performance of virtual switches, and Maryam will talk about that in a little bit more detail later on in the slides. There's also a new proposal that hasn't been approved yet, and that's Oven for NFV, and that was proposed by Vikram. I don't know if he's here. I saw him yesterday. He's going to do a lightning talk on that later on. And then there's another one, which is OVS for NFV, which Thomas is going to talk about next. So I'll just briefly introduce Open vSwitch for NFV. I suppose Open vSwitch for NFV, I guess we think that the Open vSwitch DPDK data path is a really good start to implement a performance software data plane for NFV. So the high-level intention of this project is try and upstream. We'll try to start to integrate that data path into the OPNFV stack, and then try to identify those gaps, features, and performance, and try to resolve those gaps in the upstream up into OpenVSwitch. But Thomas will talk about it in a little bit more detail. Do you want?
Well, thank you. So, again, to emphasize a little more based on what Mark said, is specifically the OVS for NFV, Open vSwitch for NFV project, is committed to working with the two upstream communities that feed us, and that's DPDK and OVS, of course. So the idea is that we hope to bring requirements that come from the telcos and the use case we find in NFV and feed them upstream to overall improve the upstream the two upstream open source projects. So again, our focus is on accelerated data plane and DPDK is the best right at the moment, the best available and the most widely accepted in the communities. And although it's not specifically stated that OVS for OPNFV is about DPDK, but it is for practical reasons. So again, and this is old hat to, or old, not red hat, to people here, in that the Open vSwitch architecture, of course, is designed to facilitate multiple interchangeable data planes, and DPDK takes advantage of that. And the issue with DPDK is, though it's an alternate data plane, it should behave identically, and it should have exact semantics. The nature of the fact that it's in user space changes the semantics a little bit. I mean, it's younger, it's faster, certainly, especially given the OVS NFV and telco use space for but very, very fast accelerated processing for a software data plane of small packets. But of course, as we all know, it has disadvantages with respect to the Linux kernel, in that the Linux kernel has 20 years worth of development and is far more mature and has a richer set of debugging options and so on. But so and this for various other reasons, they're never quite identical. So I wanted to bring that up because one of the things that we intend to work with OVS NFV is to try to discover the differences in the use cases, and with that help to improve the upstream DPDK project so it's a better citizen within the OVS community as well. So again, this is sort of our idea, and OVS NFV is to modify within the OpenStack environment OVS with kernel space or Linux kernel data plane, and replace that with OVS with DPDK data plane, and be able to deploy both or either one upstream. So or deploy either one into the NFV environment. So OVS NFV, it's a collaborative development, currently in incubation, in the sense that it's a relatively new project. It was started in July, and we are gathering requirements, and we really are working in the initial stages. And the idea is that we will deploy OVS with DPDK accelerated data plane as a package. And again, the OVS NFV, to back up a second, the OVS NFV goal is for working downstream. It's kind of downstream in the sense that although we'll build stuff from source, the idea is to build an effective product. So we're dealing with RPMs, we're dealing with glance images, we're dealing with constructs like that in OVS NFV. So our goal is to generate an RPM that can be deployed into that environment. Here's our project wiki page for comparison. Mark Gray, the gentleman to my right, is the project lead, And we have committers from Intel, Huawei, and Red Hat, as well as contributors from various other organizations. And I believe that they were all listed earlier, including Nokia and Ericsson. And we're fed by the two upstream projects. Our goal is not to fork, as Mark said, either DPDK or OVS. Instead, our goal is to enable the upstream communities and feedback changes to them. Now, there may be cases where we're going to have to take some patches that have been perhaps submitted but not merged yet in order to support the functionality of OVS NFV. And our goal is to find out these functional gaps and maybe stuff the functional gaps on the short run, but with the intention of merging, but working with upstream to merge those solutions. So some of these upstream issues that we're working with right now, and many people here are working on trying to solve some of these, but in DPDK is the difference between the device syntax, the thing that you have to use this funny utility called DPDK nick bind in order to detach an incoming interface from the Linux kernel driver to the DPDK's pull mode driver. Well, there's an upstream work being done to create a driver control utility which will make this more transparent and hopefully use systemd to manage the DPDK devices just like kernel devices are managed. So this would allow stackers and the environment to have some flexibility in device names and not be limited to the kind of syntax that DPDK might currently imposes them on devices. And other things we're dealing with is supporting, one of our goals is to support service function chaining, downstream project in OVS NFV, and the service function chaining requires some changes to on some use cases, to NSH, the way NSH is handled to pass, and this is under extensive discussion, but to pass incoming service function change from the service function forwarder to the tenant service functions, and that may require some changes upstream. And part of the reason I think that we're discussing that right now is because this comes from the need to create a sample deployment of SFC in the OPNFV environment. Another thing we're dealing with is an alternate RPM install, because we want to have two RPMs to deploy, one with DPDK data path and one with the Linux kernel data path. So right now we're talking about using glance ironic to install either data path on the compute node, and we're talking with the Apex project in OPNFV to work with them doing this. And the other possible changes is the change to the ML2 driver and DPDK OVS for legacy OpenStack deployments, and also the vhost user port names. There's a change right now that's working its way through OpenStack. So these are the kind of examples that come from the community that are affecting both these upstream projects and other related projects. So looking forward is where we're going into. Some people are calling this phase 2, but so we need to discover requirements and needed features as we go and as we move into the deployment toward the Brahmaputra release. And we want to get feedback from the OPNFV ecosystem and gather any of these missing required features and push the features upstream to improve the two communities and merge them. So this is kind of a circulatory process of continuous improvement, and that's really our goal here, is to reiterate, to not fork either project, DPDK or OVS, but to improve them by engaging in these real-world deployments. And that pretty much unless you want to break it up with questions, you probably might want to leave them for the end. And I'll pass it over to Maryam.
Hi, everyone. My name is Maryam, and I'm the VS Perf project lead within OPNFV. VS Perf is a testing project in OPNFV that aims to define, implement, and execute a set of tests for characterizing performance of virtual switches for telco NFV use cases. We have more than 30 committers and contributors from a number of different companies that we can see on the slide there. And what we're trying to accomplish within VS Perf is really three things. The first thing is to drive standardization through our test specification and our work within the IETF. So get everybody on the same page, using the same terminology, talking the same speak when they're referencing vSwitch performance benchmarks. The second thing we're trying to do is to implement a defined platform that essentially takes our test specification and puts it into practice, and that's our test framework. But we're also working on promoting its reuse both internally within OPNFV and externally to other vSwitching projects. And the final thing we're trying to accomplish is really to establish best practice. So take our test specification, take our framework, refine our methodologies, and feed back the changes or our findings right across the board. So VS Perf is involved with a number of standardization bodies and hopefully after today, open source projects. So we have contributors and committers who work in the ETSI working group that looks after vSwitch performance characterization. We have committers and contributors working within the IETF, working on essentially defining a standard based on our methodologies within VS Perf as well. So what you would normally expect the flow of information from standardization to adoption to be is what's shown in the green arrows on the slide. So essentially you'd expect some sort of standardization to happen within ETSI that gets adopted by an OPNFV project like VS Perf. We take that standard, implement it, refine the methodologies, and then we might submit a standard or an RFC draft to the IETF. And in particular, the benchmark working group there. And ultimately, that would get adopted by virtual switching projects. But what we have today is actually this feedback loop where our committers and contributors are taking our refined methodologies and terminologies and feeding them back into ETSI today. So essentially, we're helping to drive the standard platform through practical application and actually by doing, essentially. Our deliverables within VS Perf are three things. The first thing is our test specification, which we call the LTD. It's available in our Git repository or at artifacts.opnfv.org. It defines each of our tests. It goes through our approach, our general methodology, and lists all sorts of things that we should be tracking throughout each of our tests. The second deliverable is our modular test framework, which is a Python-based test framework that automates 7 of our identified tests for 3 different deployment scenarios for both standard Open vSwitch and Open vSwitch with DPDK. VS Perf, the test framework, looks after configuration of your vSwitch, your VNF if there is one. It looks after communication with your traffic generator, setting up the test, and essentially what VS Perf does is it treats your device under test as a black box. So we just set up everything, use our traffic generator as the external tester, allow the test to run, and collect the results when that's complete. The final deliverable that we're working on is an IETF draft to the benchmark working group that informs that working group of our progress within VS Perf based on specifications that started off within that working group. And we can see where each of these deliverables are consumable. So our test specification and our modular test framework are consumable by other OPNFV projects, whether they're testing or feature projects. They're also consumable by virtual switching projects. And our IETF draft is consumable by the IETF and anybody working with standards from there on. So I just kind of want to talk you through some of our approach for testing and how we go about achieving our test coverage. Our general approach within VS Perf was to adopt existing RFCs and test specifications for characterizing the performance of physical switches, and transfer these to benchmarking virtual switches. This is to allow us to have a fair comparison between physical switches and their virtual counterparts. And the next step after that then is to define tests that are specific, performance tests that are specific to virtual switches from there on. And how we track those tests is essentially through this 3x4 matrix. It's originally a 3x3 matrix that's adopted from an IETF draft called Considerations for Benchmarking Virtual Devices in Our Infrastructure, but we felt the need to extend another column to this table or matrix, which is scale, to allow us to track our scalability tests. So essentially today we track our tests under the categories of speed of activation, speed of operation, speed of deactivation, and so on and so forth. This table is the reflection of our current test specification to date. The white tests are tests that are being added to the test spec or are currently in review. So we have, we can see from this table that there are a few categories that are relatively light on tests, or tests that require tests to be added to them. So that's something that we'll be looking forward to doing in the future. So I just wanted to talk to you about some of the future work that we're considering, that's under consideration for OVS Perf. We're integrating multiple traffic gens. Today, ICSI and Spirent are supported, but we're looking at software packet generators as well, like MoonGen and Xena. We're looking to continue to extend our methodology and prove out and refine our methodology and tests through the framework. And we're going to continue to add more tests to the LTD and the framework itself. We're also going to start integrating in some of the continuous integration frameworks within OPNFV and supporting some of the projects there. And finally, the last thing we're kind of looking into is also implementing some of the deployment scenarios that are closer to real-life deployments like in OpenStack. So finally, I just wanted to ask you folks to come and join us in OPNFV to help establish an open source carrier-grade integrated platform that includes carrier-grade open vSwitch. After all, success is a sum of small repeated efforts day in and day out. Thank you.
All right, we have time for one or two questions.
Good talk. Thank you very much. I have a question regarding OVS for OPNFV. You mentioned that you're not doing a fork. At the same time, you also mentioned that you're including patches which might not have been merged into OVS yet. How do you handle a situation where a patch that you packaged does not get merged in the same form into OVS?
This is a conversation we had all last week. It's a difficult one. We haven't quite figured it out yet, but we definitely don't want to fork. But there's a realization that for some of the projects, we may have to maintain patches out of tree for a little while to hit their OPNFV release, but we haven't figured that one out yet.
Yeah, that's kind of a placeholder of just a realization that dealing in the real world, that some of the upstream projects could have a long time to merge, and we may be ahead of them. So we're stating our goal is to not forking, and hoping that any situation like that won't be perceived as an effort to fork.
It's a very slippery road, and it's an almost fork. I know, I understand the intention. It's a very slippery road.
Yeah, I think definitely no long-term fork. I mean, I know the pain of maintaining an open vSwitch fork, and it can be a bit of a pain, really. So I think we'll have to maintain some patches, maybe temporarily, but not long-term. And hopefully by working with the open vSwitch community, and when you guys see what we're trying to do, it'll help us get those patches upstream quicker into the open vSwitch community.
Okay, I think we have time for one question here. Chris?
So related to Thomas's question, the real value I see of this effort is to show performance numbers, and I know you weren't trying to show those numbers here. Performance numbers and real world benchmarking use cases. We can talk separately offline about all the reasons why I will push hard against you ever releasing anything in an OPNFV release that's a forked component of an upstream project. But I'd really like to understand where we're going to start to see numbers, because I think what you said there, Mark, at the end was showing value to the OVS community. And what I've seen, I have a lot of concerns about DPDK and the duplicate functionality that Tom mentioned, and some of the benchmarking numbers that aren't really reflective of real-world use cases. So I'm really looking forward to your clarity and understanding what those benchmarks look like, and when are we going to see those, and how are you going to communicate those to this community?
So I can answer that. For release B, unfortunately, our focus, because of the amount of tastes we've been implementing, is just to provide pure baselines of the two versions of OVS, standard OVS and OVS with DPDK. For release C, we're actually integrating with some of the other testing projects within OPNFV, like Yardstick, which does verification of your full OPNFV deployment. And what you'll see there then is our tests being leveraged by Yardstick, so you can do the full test that we've defined within VS Perf right across the OPNFV deployment. The results will be published and will be externally visible through another effort within OPNFV, which is called the OPNFV test dashboard. So any test that runs within OPNFV from a testing project in any OPNFV federated lab will push the results of those tests externally to a database, which is then published through the OPNFV website. So over release B, release C, essentially, is when you'll start seeing some real numbers.
The real question is, those numbers are irrelevant here unless somebody takes an active role in bringing that data to this community and really showing the patches plus the performance numbers here. Otherwise, it's just information on a website somewhere that isn't going to be impactful.
Sure, and I think we recognize that, which is why we're here today, trying to get the community to participate in OPNFV.
Thank you.
Thank you.
All right, let's thank our speaker one more time.